ACC0, sometimes called ACC, is a class of computational models and problems defined in circuit complexity, a field of theoretical computer science. The class is defined by augmenting the class AC0 of constant depth, alternating circuits, with the ability to count. The acronym ACC stands for AC, with counters. Specifically, a problem belongs to ACC0 if it can be solved by polynomial size, constant depth circuits of unbounded fan-in gates, including gates that count modulo a fixed integer. ACC0 corresponds to computation in any solvable monoid. The class is very well studied in theoretical computer science because of the algebraic connections and because it is one of the largest concrete computational models for which computational impossibility results, so-called circuit lower bounds, can be proved. Definitions. Informally, ACC0 models the class of computations realized by Boolean circuits of constant depth and polynomial size, where the circuit gates includes modular counting gates that compute the number of true inputs modulo some fixed constant. More formally, a language belongs to AC0 if it can be computed by a family of circuits C1, C2, where Cn takes n inputs. The depth of every circuit is constant, the size of Cn is a polynomial function of n, and the circuit uses the following gates. AND gates are NOR gates of unbounded fan-in, computing the conjunction and disjunction of their inputs, NOT gates computing the negation of their single input, and unbounded fan-in mod m gates, which compute 1 if the number of input 1s is a multiple of m. A language belongs to ACC0 if it belongs to AC0 for some m. In some texts, ACC refers to a hierarchy of circuit classes with ACC0 at its lowest level, where the circuits in ACC have depth O and polynomial size. The class ACC0 can also be defined in terms of computations of non-uniform deterministic finite automata over monoids. In this framework, the input is interpreted as elements from a fixed monoid, and the input is accepted if the product of the input elements belongs to a given list of monoid elements. The class ACC0 is the family of languages accepted by a NUDFA over some monoid that does not contain an unsolvable group as a subsemigroup. Computational power. The class ACC0 includes AC0. This inclusion is strict, because a single mod 2 gate computes the parity function, which is known to be impossible to compute in AC0. More generally, the function MODM cannot be computed in AC0 P for prime P unless M is a power of P. The class ACC0 is included in TC0. It is conjectured that ACC0 is unable to compute the majority function of its inputs, but this remains unresolved as of July 2014. Every problem in ACC0 can be solved by circuits of depth 2, with AND gates of polylogarithmic fan-in at the inputs, connected to a single gate computing a symmetric function. These circuits are called simplus circuits. The proof follows ideas of the proof of Toda's theorem. Williams proves that ACC0 does not contain any exptime. The proof uses many results in complexity theory, including the time hierarchy theorem, IP equals PSPACE, de-randomization, and the representation of ACC0 via simplus circuits. It is known that computing the permanent is impossible for log-time uniform ACC0 circuits, which implies that the complexity class PP is not contained in log-time uniform ACC0.